Welcome everyone to Algebra 2, Section 1.3. This is writing equations of parallel and perpendicular lines. So this learning target is comes straight off of that, saying students will be able to write linear equations of parallel and perpendicular lines. Our warm-up is going to be to review from last lesson 1.2, where we were writing equations in slope-intercept form. So write the equation of the line given 2 points. So when we're given 2 points, remember we have to find m and then find b in order to plug it into y equals mx plus b. So in order to first find the m, we have to say which one of these we want to go first and do y2 minus y1 and x2 minus x1. So as far as the y's go, they're the exact same. They're both 2 and 2. I'm going to go ahead and pick this point first, because then since I can't pick a bigger y, I'm going to pick a bigger x, and -1 is bigger than -4 because it's less negative. So 2 minus 2 on the top, and -1 minus a -4 on the bottom. On the top is going to give us 0. On the bottom, 2 negatives in a row like that give us a plus, so it's over 3. But 0 divided by any other number is still 0. You might notice something special now since the slope is 0. Remember what happens when the slope is 0. We have a particular type of line. It's a horizontal line. Now, if you do remember that you have a horizontal line, and horizontal lines are always y equals a number, because remember, if they're horizontal, the y value is never changing because it's never going up or down, even though it's going left and right, so the x changes. So it's y equals a number, and because they're both 2 for the point, it's going to be y equals 2. Now let's say you don't remember that. How you would go about solving this problem is you use your m, and either of these points, I'm going to pick the second one because it's slightly smaller, in this case slightly closer to 0, less to deal with than the -4, I should say. And I plug them into y equals mx plus b. So I get 2 for the y, that's the y value of the point, equals 0 for the slope, times -1 for the x value of that point, plus b. And as we start solving this problem, this equation, we get 0 times -1 is 0, and 0 plus b is that, 2 equals b. So we end up back in the same spot where we know the b is 2, the y-intercept, so we can plug it back in to y equals mx plus b and leave y and x as y and x. So you have 0 for the slope and plus 2 for the y-intercept. But once again, that takes you right back to the same spot where 0 times x is 0, and you just have y equals 2. Number 2. Convert this equation from slope-intercept to standard form. This is going back to section 1. So, remember, slope-intercept is y equals mx plus b. Standard form might be what you're rustier on. Standard form is ax plus by equals c. And the things you really need to remember is that both x and y are on the left side of the equation, and that the a, aka the number with the x, has to be positive, and there can be in the entire equation no decimals or fractions. Well, currently all 3 of those are issues. X is on the right side and y is on the left. They both need to be on the left. X is negative, but it needs to be positive. And there's a fraction. There's not supposed to be fractions. So first things first, let's get them on the same side. So I'm going to add 1/5 to each side, 1/5 x I should say, and get 1/5 x plus y equals -2. Now I'm going to deal with the fraction, because the negative actually took care of itself when I added 1/5 x to both sides. So I'm going to multiply by 5 over 1, aka multiply by whatever the denominator is there in order to get that to work. And remember, that's on both sides of the equation or to the whole equation. If it works better for you to write it like this, multiplying this side by 5 over 1, and multiplying this side by 5 or 5 over 1, write it that way. Really, whatever works best for you is what matters. So 5 and 5 reduce. For that, So it ends up being just a 1 extra x. But don't forget that that also multiplies to the y when it's still 5. So it has to be 5y. The common pitfall could be to reduce those and then think, oh, I'm just taking 1 times y and calling it just y. But you have to take the original 5 times it. So if it'd be easier for you to keep it straight by doing this work off to the side, do it off to the side. Do 5 over 1 times 1 over 5x off to the side, and then bring that back in to your problem. On the right side of the equation over here, negative 2 times 5 is going to be negative 10. And so now let's make sure we kind of hit our 3 things we're supposed to for standard form. X and y are on the left, good. That the number with the x is positive, it is, no negative sign there. And that there are no fractions and decimals in the entire equation, and that is also true. So, we're done. All right, on to the new stuff today. So, parallel lines. Parallel lines are 2 lines on a plane. Remember from geometry, plane is just where everything is. So lines, rays, shapes, whatever. So 2 lines in a plane that never intersect, aka they never touch. And parallel lines will always have the same slope. Now you might remember, you might not, that the symbol for parallel lines is 2 slashes like that, because they kind of look like mini parallel lines. Sometimes you'll see it written straight up and down. Most common you'll see the slant though, the slash, so that way people don't confuse them with like the number 11, for example, or LL. Perpendicular lines. 2 lines in a plane that intersect, but they intersect specifically at a right angle, which you may recall is 90 degrees. Their slopes are opposite reciprocals of each other. Now I want to clarify, opposite means opposite sign. So one's positive, one's negative, and reciprocals is flipping the fraction. Might not be a bad idea for you to write that in there. The symbol for perpendicular lines is an upside down T. So it kind of looks like perpendicular lines if you were to continue that down, but we don't want to do that because then it looks like a plus sign. So we just go with the upside down T. All right, example 1. We're supposed to tell whether these lines are parallel, perpendicular, or neither. L1 and L2, that stands for line 1 and line 2. So we're saying line 1 has these 2 points. Line 2 has these 2 points. Now, in order to tell whether they're parallel, perpendicular, or neither, we need to look at the slope, because both parallel and perpendicular lines have special things going on with their slope. So we need to find the slope of both lines. So we might recall from last section and the warm-up how to find the slope of these 2 points. You do m equals, and you start subtracting y's and x's. And I'm always going to pick the bigger y first. So I'm going to do 2 minus negative 1 over negative 2 minus 0. The double negative gives me 3 on top when I add, and negative 2 minus 0 is negative 2. So the slope is 3 over negative 2. Now I need to find the slope of this other line. So I do the same thing. M equals 3 minus negative 1, or the reverse, over 2 minus negative 4. And I'm going to be adding in both of those again, and get m equals 4 over 6, which reduces to 2 over 3. Now those slopes are not the same, 3 over negative 2 and 2 over 3, so they're not parallel. So the question becomes, well, are they perpendicular? So we have to say, are they opposite signs? They are. 2/3 is positive, negative 3/2 is negative. Are they reciprocals? They also are. 2 is on top, 2 is on bottom. 3 is on top, 3 is on bottom, and 3 is on top. So they are perpendicular lines. So you can do the symbol, or you can write out perpendicular, or you can abbreviate PERP. So once again, we found the slopes, and then we compared the slopes. Now on to letter B. You might want to do this on your own. Pause the video, and then watch the video after I'm done. after you're done, excuse me. So one thing I'm going to continue to do on these, or so I'm going to start doing on these, is start writing the slope as m of line 1. So it's like written below it there, kind of like when we do y2 and y1, same idea. We're just putting that L1 below it. And you might realize, and you might not, that's okay, that that is line 1. So we're just saying, hey, the slope of the first line is what we're doing. Then later, we'll do the slope of the second line and solve for that. So the slope of the first line, I'm going to do 1 minus -5 over -2 minus 0. 1 plus 5 ends up being with double negatives, 6 over -2, which becomes -3. The second line, I'm going to do 10 minus 1 over -3 minus 0. That's 9 over -3, which is -3. You might notice, hey, those are the exact same. Even the sign has to be the same, but they are. So these lines are parallel, which you can do the symbol, or you can write it out. And once again, I could even just put the L1 back on the first problem we just did in L2 there, just to emphasize, hey, those are line 1 and line 2. Might not be a bad idea. I'm going to do it from here on out on problems like that. On to page 10 here, writing equations of parallel and perpendicular lines. So that's what we said we were going to be doing today. So 2 steps. Step 1, identify, which you could shorten down to ID if you want. Identify what slope, aka M, you should use. And that's just saying, hey, you use the same slope if they're parallel, or you use the opposite reciprocal slope, which I'm going to shorten down to OPP for opposite, and recip for reciprocal. You can write it out if you need to, that's okay, if they're perpendicular. So that's all that's saying is, hey, it'll be the same if they're parallel, opposite reciprocals if they're perpendicular, like we just talked about. And then step 2, use y equals mx plus b, that same equation we've been using from last section and before, and the point that we're given, because it will always be given a point for these, to write the equation of the line. So if you recall from last section, we'll be using in step 2, we'll be finding the b and then plugging m and b into the equation to be done. So on example 2, we're given an equation, or excuse me, we're supposed to write the equation of the lines that are parallel and perpendicular to the line 3x plus y equals 1 and pass through the point -2, 1. So we're going to have 2 different problems here. One for the parallel line, and then we'll stop, and then we'll go on to the perpendicular line. So first, the first one needs to be parallel to this line, aka they need to have the same exact slope. So this is what step 1 is saying, identify what m you should use. So we know they need to be the same, but we also have to figure out, well, what is the slope of this line? It would be easiest for us to tell what the slope is if we get y by itself, which we can do by subtracting 3x from both sides. So we get y equals -3x plus 1. Now we can more easily tell that the slope of this line is -3. So the slope of the parallel line is also -3. Notice I just did the same little thing I did with the L1, the slope of line 1, or L2, the slope of L2, with parallel there, saying, hey, the slope of the parallel line. You don't have to write that, but I choose to just to kind of organize it a little bit better for me. So now we have the slope, we have a point that it's supposed to pass through, so we're going to use those to find the b. So we take our y equals mx plus b, and we plug in y for the point, so 1 from the point, its y value, equals -3 for the m, times -2 for the x, plus b, which is what we're trying to solve for. 1 equals positive 6 plus b. That might get a little confusing there with a 6 and a b right next to each other, especially with my poor handwriting. Subtract the 6 from both sides, and you get negative 5 equals b. Now that we finally have our m and our b, we can take those and plug them into our y equals mx plus b and get y equals negative 3x minus 5. So that would be the equation of a line that is parallel because it has the same exact slope as the original line, and it passes through negative 2 comma 1 because we made sure it did when we used negative 2 comma 1 to help find our b. Onto the perpendicular line. We already found the slope of the original line, so we know that's m equals 3. Now we need to say, well, for the perpendicular line, we're not just going to use negative 3 again. This time, we need it to be opposite sign, so it'll be positive, which we like, but we have to reciprocate it, which we don't like what we're going to have to do here because we'll have to make it a fraction. Because 3, just like any number, is secretly always over 1. So the reciprocal is 1 over 3. Assuming that should be a negative 3 over 1, which makes the opposite reciprocal, aka the slope of the perpendicular line, like I did the little symbol there, is positive 1 over 3. So now we use this slope and the point that we're given for it to pass through in order to find our d. So 1 equals 1/3 times negative 2 as the x plus b. As we solve this time, 1 equals, might be a good idea to put negative 2 over 1, nothing to reduce though, so you just have negative 2 over 3 plus b. So you have to add 2/3 to both sides. Once again, it might be a good idea to do some work off to the side there. So I'll say, hey, that's 5/3 equals b. If you can't do that right without doing the work off the side, do that off to the side, please, please, please. It'll help you. If that's the case, do it. So off to the side, I'll do that work real quick, saying, hey, 1 plus 2/3 is secretly going to be multiplying by 3 to get 3/3 plus 2/3, which is 5/3. So you can always do it off to the side. So I have my m, I have my b, I can finally write my equation. Y equals 1/3 x plus 5 over 3. And that is my equation that is perpendicular because it is the opposite reciprocal of the original slope. And it passes through negative 2 comma 1 because that's what we used when we found the b. You could also double check that it passes through that point if you want by plugging in negative 2 for x and making sure you get 1 back out for the y. If anything else happens, you get anything else out, then you did something wrong. Continuing on. Excuse me. Shouldn't continue on yet down to that slide. Probably had some of you very confused. We're continuing on to example 3, which is further down the same page. So, write the equation of a line that is perpendicular to y equals negative 1/3 x plus 7 and pass through the point negative 3 comma 6. So we're told it's perpendicular. So this slope of the original equation is negative 1/3. The slope of the perpendicular equation will be 3, or 3 over 1, because it has to be the opposite sign, and you reciprocate it. We're given the point, so we're going to use that point and the slope to find the b. 6 equals 3 times negative 3 as the x value plus b. 6, which I want to make sure is not the b, like I'm not confusing that for the b, I mean, is equal to negative 9 plus b. Add the 9 to both sides. Sorry about that. Add the 9 to both sides, and I get 15 equals b. Now that I have the b and the m, making sure I don't accidentally use the original m, the perpendicular m is what I want, I do y equals 3, x plus 15. Number 4, write the equation of a line that is parallel to y equals 9. Okay, might want to start remembering y equals 9, y equals 9. What kind of line is that? Well, think whenever you have x or y equals a number with nothing else in the equation, it's either going to be vertical or horizontal. So you got to figure out, well, which one is it? Well, if you were to have a little graph here and you say, hey, y is always going to be 9. Okay, so 9 is going to be, let's say, up there on the graph somewhere. That means for it to always be 9, it has to be going horizontally because it cannot go up and down. So it's a horizontal line which has that slope of 0. So if you want to do y equals 0x plus a b, you can, but remember, once again, any parallel line will have the same slope of 0, so it'll also be horizontal. And this time on example 4, it's different because it's not telling you that you have to have it go through any specific point. So it's giving you a lot of freedom here to really pick whatever point you want it to go through. So I could call it y equals 5 if I want. Another student might call it y equals negative 8, and that would be perfectly fine. Another student might call it y equals 85. That'd be perfectly fine as well. Really, what matters is you have y equals some number as your answer. As long as you have that as your answer, you are good. Now we'll continue on. Oh, I'm sorry, that is not continuing on. That should not be on this presentation because that is not in this section. So that is it for section 3.